Okay, today I'm gonna start improving my Brickout game a little bit. Improve how the bat works and how the um, bowl trajectory and maybe speed a little bit, and see if I can add some better functionality. I'm gonna start with changing where the ball starts to, so that it's not already helping us out. So let's make that happen. So I'm going to my breakout game, um, and this is my object, and that's the ball essentially, but it's starting at position 10, 5. Instead of that, let's do that mathematically a little bit. Let's see screen width in the middle of the screen, and then get the height. I don't think I can do the middle because there's bricks there, so I'm going to start 3/5 of the screen. Let's see how that looks like. Oh, that was quick. That's okay. You can start with that. Do you want to make the bricks go all the way to the right? It's missing one column. I'm just gonna, so this is how many bricks are in a row, and this is like the 5 loops. I need to make this a function and send in parameters, the offsets and everything, but it's let's let's just do this for now, cheap and dirty. Once we get it working, we can optimize it. It's kind of how I do things, so it's easy to change it around. All right, so that's a starting point. Okay, so with that, let's see. So the speed, unfortunately, the speed, I have one variable. So let's make that 2 different speeds for x and y position directions. So let's split that into 2, and since the width is, there's more width on the screen than the height, it's easier to um, kind of work with the x. At least let's start there. Since we have a floating point, we can kind of fake increment it by little increments like 0.5 or something like that if you need to, or 1.5 to make it faster. Um, and did, let's see, so didn't do anything other than just change the speed. So now what I would like to do, when it hits the bat, I want to, let's do a math to get the difference. So yeah, ball position, and if I do diff it's sense helping, but difference is 1/3 the bat length. So if it hits the front side, I want it to see speed x equals 1.5. No, I want actually the direction to be switched. If it hits, we need to know the direction. Okay, so I need to know the direction where it's coming from. So if it's coming this way, that means from, yeah, addition. So if it's positive, we want to, uh, okay, if it's positive, at sign, if it's positive, what we want to do, if it's on the first 1/3, if it's positive, just change direction. But if it's negative, that means coming from this side, I want to make it faster going the other way. So I want to just do speed x equals 1.5 f. Alright. And then I want to, actually I want difference is less than the bed length. So that's the first 1/3. And then here, else, if it's the last 2/3 to the right corner, I want to switch this to around. And then if it's in the middle, I guess any else case, since we got the two other thing, what do we do if it's in the middle? Do this, just normal bounce. Yeah, let's try that. Yep. Oops, it didn't work on the right. The left worked. Alright, just, let's see. Oh, this needs to be greater than. Alright, so less than 1/3, greater than 2/3, and then whatever's left. That should work. I don't know if it's, maybe we'll exaggerate it. Let's say 2. Still something off. Okay. If the direction is positive, change the direction. The direction is positive, then I speed it up. Alright. I guess I can put a stop here. It's not like I can't stop and debug it, right? Alright, so it hit on the right corner, so It's getting in there, so it was coming down this way. That means x should be positive. It's true. Speed is gonna be 2. Speed x is what we changed. Alright, so I want to go back up here. Oh. Since I changed the speed, I need to actually assign it to the balls, the x direction too. So I didn't do that. Let's do the x. I want to assign it, but I want to preserve the sign of the x direction times speed x, because I don't want to change direction, because I don't know what it is. I know what it is, I just want to preserve it, and then I want to assign the new speed. Alright, let's try that. Whoa. Definitely working. Alright, so 2 is a bit much. Let's do 1.5. That might be still be too much. Okay. That's a normal bounce. Normal bounce. Ah. Okay, let's now that's 1.5. Okay. That looks about accurate. I don't want to get too out of control. Depending on the level, when I build levels, I'll change these numbers. All these numbers need to be parameterized. Again, this is how we learn, how I learn. So let's keep working on that. So that works. I also want to speed it up when it collides with the brick. So let's do that. So here I'm going to do speed x. Do 0.1 x and y. So increment them both, and then let's see, x direction. Now I want to do the same thing I did since let's steal this code, updated them. Let's do that for the y too. And so it increments it, but once it hits the bat again, it resets it to 1 and 1.5, which is reasonable, but this could get out of hand if it's really fast. Well, let's see what it does. So as it hits brakes, it's gonna get faster and faster. What happened? Well, I think I know. I had my constraints set to equal. Since it's float and since it's checking for equal, so I want it so greater or equal. That way, y becomes greater than the height. It should end the game. I think there might be another place. It's greater, no? No, I guess that's it. So everything else is greater. Alright, let's try that again. No, yeah, the bat position too. So yeah, that would be. There's my bat. There's my bat. The code is getting out of hand. Oh, this is the bat. So, all right. So that one, if y is equal, greater or equal, so it's could be slightly below the y, but it's still within the x boundary. All right. There you go. So I'm eventually gonna try to use OpenGL or something like that to actually play around. Oh wow, I got super fast. Okay. It worked. It sped up, but it got really fast, really quick. So let's make it like that, and then as it hits the walls, let's make it one for now. If it hits one of the top three walls, it should slow down. Oh, reset. And then, so technically, if you manage to hit a lot of bricks, you might end up hurting yourself. Again, just playing around. We can add more logic as we go. Oh, it's speeding up. Whoop. I think what we need to do is put a cap. Let's say um, equals math max between that and let's say 1.8 or something like that. So they would cap at that, so it doesn't get unreasonable. So we could shrink this down a little bit. No, do this. Wait, what did I do here? So it keeps adding. Okay, that should work. What? Why is it getting? Oh, this one. Let's make this 2. Don't want it to get too aggressive. What is going on? Point one. Oh, not max. Min. No. Okay, so if it keeps growing max. Yeah, we want the min. So keep increment till 1.8. After 1.8, it's just 1.8. So it doesn't increment. Whew. All right. Okay, I thought I fixed that. The bat. If ball position greater or equal to y. Should have gone here. Oh, it also go here too, probably, and think it's end. I'm gonna cheat here. Bat. Let's say card. Guess there's better ways to do this, but that means I caught the ball. So let me ignore this situation. And not. So now I'm not gonna exit the game if it thinks it's below, especially since I'm doing decimal points. Yeah, see, it just goes a little bit below the bat. Alright, cool. I think that's enough for today of this video, and see you next time. Thanks for watching. Bye.